parallel circuit today, guys. So let's draw a parallel circuit with three branches. So we have a switch, branch 1, branch 2, and that's my resistor. Don't laugh at them. We're going to call this R1, R2, and R3. We're going to give this 10 ohms. We're going to give this 5 ohms. And we're going to give this, let's get a nice number, 20 ohms. Right? And we're gonna find the total voltage, total resistance, total current, the voltage drop in each branch, and the current flowing through each branch. So as usual, we have 120 volts as our source. So the first thing we're gonna do, guys, is we're gonna find the RT. All right. The differences between a series circuit and a parallel circuit. Series circuit has one path for current to flow. Parallel circuit has multiple paths. So this one has 3 paths, right? So the first thing is we're gonna find a total resistance. Our total resistance is RT is equals to 1 over 1 over R1 plus 1 over R2 plus 1 over R3. This formula can be used with any parallel circuit. It's called the reciprocal formulas, all right? And it's used 100% of the time. And I'm choosing this one because we have 3 loads. So show all your work, show your formulas, put the numbers exactly where they go. So the first thing we do is we put our formulas, right? The next thing we do is we're gonna put the numbers in now. So we're gonna go RT is equals to 1 over, what's the value of R1? 10. What's the value of R2? 5. And what's the value of R3? 20. So now that we do that, now we have to put them in decimal. So now this is where I need your calculator support. So RT is equals to 1 over, do not forget the 1. 1 divided by 10 is 0.1 plus, what's 1 divided by 5? That should be 0.2. And 1 divided by 20 should be 0.05. So now I want you guys to add up 0.1 plus 0.2 plus 0.05. It's a pretty easy where I can see it's 1 over 0.35. Right? We're still not done. Now we gotta go 1 divided by 0.35. What's that equal to? So RT is equal to 1 over 0.35, which is equal to what? What's 1 divided by 0.35?
2.9.
So we got 2.9. That is my RT. We did all that for the RT. Again, that's step number 1. Okay? Step number 2 is my ET, or my total voltage, and that's 120 volts. That's already given to us. So we put 120 volts. And my total current is always going to be my total voltage divided by my total resistance. And you know me, I like to put my numbers where they go. That's equals to 120 divided by 2.9. And that's equals to what? What's 120 divided by 2.9?
41.4.
So we got 41.4, right? And that's my step number 3, right? Step number 4 is a statement. Again, it's a statement. This is a parallel circuit. In a parallel circuit, whatever your total voltage is, that's what all your voltage drops will be. And in this case, it's 120 volts. So again, if you have 120 volts here, between here and here is 120 volts, 120 volts, 120 volts. They're all 120 volts. Now we have step number 5 is to find my IR1, which is the current flowing in each branch. That will be equal to my voltage at that branch divided by my resistance, which is equal to 120 divided by 5. That equals to 20. I'm sorry, this will be 10. So let me erase that. That's 120 divided by 10. And that's equals to 12. IR2 is equals to ER2 divided by R2, and that's equals to 120 divided by 5, and that's equals to 24. And the last one is IR3, which is the current going through R3, is E3 divided by R3, and that's 120 divided by 20, and that's equal to 6. All right, my total current, according to you guys, was 41.4. If I add 12 plus 24, that's 30, plus 12, that's 42, so it's close enough to 41.4. That's known as Kirchhoff's current law. Again, if my total voltage, if my total current is 41.4, this plus that has to be close to 41. Again, it's going to be different because of the 2.9. We didn't use all the decimal places. If we used all the decimal places, it will be closer to 42. All right, now that's what we did right here. Was we found our total resistance, we found our total voltage, our total current, we found all the voltage drops, and we found all the currents. Now, we can also, if I give you extra credit, I said, do me a favor, find the power, right? You can use any formulas to find the power. You can go P is equals to I times E. So it will be, I times E would be 12 multiplied by 120, because all the E's are 120, or 24 times 120, 6 times 120. That's what we use the P. We can say P is equal to E squared divided by R. That would be 120 times 120 divided by any of these. So let's say we're trying to find this one. It'll be 120 times 120. And again, do basic math. 12 times 12 is 144. And you do the 2 zeros. Divide by 10. And that will be 1440 if we're doing that formula. Or we can use P is equal to I squared times R. And that would be any of these. So it would be 12 times 12 times 10, which is still going to give you 1440. Again, you can use any formula to find the power. Okay, so that's how we solve a parallel circuit. Any questions? Circuit that has two loads, right? Again, I'm not going to solve the entire circuit. So this one is 10, and this one is, let's call, what do we call this? 10 and 50, right? And we want to find the RT. All right, we'll call this R1, R2. Okay, R2. So again, the first step is to find my total resistance. How many loads do we have in the circuit? We have 2 loads. So we're going to go R1 times R2 over R1 plus R2, and that's equals to 10 multiplied by 15 over 10 plus 15, which is equals to 150 over 25, and that's equals to 6. That formula is a lot better, but it can only be used with 2 loads. If you have 3 loads, you can apply the formula twice, and you can avoid all the fractions. You can avoid all the decimals. All right? This is called a product sum. Okay? And it should only be used with 2 loads. Again, step number 2, my ET is equals to 120. Step number 3, my total current is equals to my total voltage divided by my total resistance. That's 120 divided by 6, and that's equals to 20. All right, step number 4, this is a parallel circuit, so my total voltage is 120, and that's equals to my ER1 and my ER2. Step 5, my IR1 is ER1 over R1, that's 120 divided by 10, that's equals to 12. And my IR2 is ER2 over R2 equals to 120 divided by 50, and that's equals to 8. Again, if you add them up, you're going to get 20 amp. My total was 20 amps. So that's Kirchhoff's current law. It adds up. Alright? We're going to do one more. Alright? Just to show you another formula. Okay, so let's say you have, so we're going to pick some numbers. We're going to do 3 loads. We're going to make it quick. Alright? So I'm drawing another circuit. And I have 3 loads. That's 120. So we got 3 loads in the circuit. R1, R2, and R3. This is 30 ohms. This is 30 ohms. This is 30 ohms. Okay? These are all the same value. They're all 30 ohms. So we can use a third formula, and this formula can only be used if they are the same value. It's called the equal value. And that says it's the value of load divided by the numbers of load. So in this situation, the value of the load is 30. How many loads do we have? 3. So my RT would be 10. It's that simple. We can figure, again, I'm not gonna solve the circuit, but let's go ahead and use the equal value. Let's use the product sum. The product sum can only be used for 2 loads. Don't forget. So what we're gonna do, guys, we're gonna just work on this half of the circuit. Let's work on these 2. So we're gonna go R1 times R2 over R1 plus R2, and that will be 30 times 30 over 30 plus 30. That's 900 divided by 60. That's equals to 15, right? Double check my math, please double check my math. What's 900 divided by 60? Nice, okay, that's 15. So now these two is 15. So now we go 15 and 30. So we can go 15 multiplied by 30 over 15 plus 30. What's 15 multiplied by 30? 300? I don't remember.
450.
450? Way off. 450. What's 15 plus 30? 45. Again, 45 to 45 is 1. 45 to 450 is 10. We still got the 10. Alright, guys? We can literally go the first formula, which is 1 over 1 over 10 plus 1 over 10 plus 1 over 10, which is equals to 1 over 0.1 plus 0.1 plus 0.1, which is equals to 1 over 0.3. And what's 1 divided by 0.3?
3. It's like, it's kind of carrying numbers. 3.333.
3.33333?
Yeah.
Then what did I do wrong here? Oh, dude, you guys didn't see what I did? What's 1 divided by 10?
1 divided by 10. That's 0.1, right?
0.1, right?
Sure.
0.1. So 1 divided by 10, 0.1. 1 divided by 10, 0.1. So 0.1 plus 0.1 plus 1 is what? So why aren't we getting 10? What did I do wrong?
1 divided by 10, and then you did plus 1 divided by 10, 0.0. Alright.
Oh, I see what I did wrong. It's good for the lecture. I'm going so fast, I'm messing up. Alright, so none of you guys spot the mistake. So it's 1 over 1 over 30 plus 1 over 30 plus 1 over 30. What's 1 divided by 30? 0.03333 plus, you gotta keep going, right? Then you're gonna go 0.0333 plus 0.033 0.03. Alright, that's equals to what's 0.0333 plus 0.033? Add them all together, tell me what you get.
Wouldn't it be 0.09999999?
Yeah, it'll be 0.1. Yeah, so it'll be 1 over 0.999, which is close to 1, which is going to be equal to 10. Alright, so again, you can use any formulas, but depending on which one is easier for you. But if I'm giving a quiz, guys, obviously I'm not giving 30, 30, 30. And I'm not even going to give you 2. I'm going to give you numbers where you have to use these formulas. Any question? All right.